General form of quadratic functions, section 3.2. The general form, also called the intercept form of quadratic functions, f of x equal ax squared plus bx plus c. It's called the intercept form because it's easy to get the intercepts once you know a, b, and c here. The y-intercept, f of 0, 0 plus 0 plus c would equal c. The two x-intercepts are given by the quadratic formula. X equal minus b plus or minus square root of b squared minus 4ac all over 2a. The x-coordinate of the vertex is minus b over 2a. Actually, if you just remove the square root from the quadratic formula, that gives you the formula for the x-coordinate of the vertex. The vertex is halfway between the two x-intercepts. And by the way, there's not always going to be any x-intercepts. There could be 0, 1, or 2 x-intercepts, but if there are any x-intercepts, it'll be given by this formula. Sometimes there'll be no real solution if you plug in to this formula here. Okay, so example, f of x equal x squared minus 8x plus 15. The y-intercept would be f of 0. 0 minus 0 plus 15 is 15. X-intercepts, usually if it can be easily factored, it's faster to factor it. You could also use the quadratic formula, but I usually like to try factoring first. If it's hard to factor, then I use the quadratic formula. So we want to set f of x equal to 0, x squared minus 8x plus 15 equals 0, and solve for x. We can try factoring. X times x is x squared. Then we need two numbers to multiply to 15 and add up to negative 8. And what works is negative 3 and negative 5. You can check with the FOIL method. X times x is x squared. Outer product is negative 5x. Inner product negative 3x. Combine those, you get negative 8x. Last times last, negative 3 times negative 5 is positive 15. Then we have a product equals 0. That means one of the factors has to be 0. X minus 3 equals 0, or x minus 5 equals 0. Add 3 to both sides to the first equation, you get x equal 3. Add 5 to both sides of the second equation, you get x equal 5. So those are our x-intercepts, 3 and 5. And if you get stuck factoring, you could use the quadratic formula. And then we need to identify a, b, and c. A is the number in front of x squared. If there's no number there, then a is equal to 1. B is the number in front of x, which in this case was negative 8. C is the number by itself, which in this case is 15. And then replace the letters with the numbers in this formula here. So x is equal to minus b plus or minus square root b squared minus 4ac all over 2a. And putting in the numbers, we get x is equal to negative 8 plus or minus square root negative 8 quantity squared minus 4 times 1 times 15 all over 2 times 1. A double negative becomes positive. That's a plus 8 plus or minus square root negative 8 squared. Negative 8 times negative 8 is 64. And negative 4 times 1 times 15 is negative 60. On the bottom we'll have 2 times 1, which is 2. And then you do the subtraction underneath the square root. 64 minus 60 is 4. Take the square root of 4, you get 2. And so we'll have 8 plus or minus 2 over 2. Then we can split up the plus or minus. So that's 8 minus 2 over 2, or 8 plus 2 over 2. 8 minus 2 is 6. That gives us 6 over 2. 8 plus 2 is 10. That gives us 10 over 2. 6 divided by 2 is 3. 10 divided by 2 is 5. So again, we have the same answer, x equal 3 or x equal 5. Okay, so the x-coordinate of the vertex. The vertex is halfway between the two x-intercepts. So regardless of how you found the x-intercepts, once you get the x-intercepts, you can compute the vertex. 3 plus 5 is 8. 8 divided by 2 is 4. So the x-coordinate of the vertex will be 4. Y-coordinate of the vertex, we just evaluate f of 4 to get the y value. So f of 4 is 4 squared minus 8 times 4 plus 15. And that comes out to be negative 1. So the y-coordinate of the vertex is negative 1. Okay, so we can use this information to sketch the graph. We have the y-intercept when x is 0, y is 15. We have the two x-intercepts when x is 3, y is 0, when x is 5, y is 0, and then we have the vertex when x is 4, y is -1. So then we can plot the points and sketch the graph. So we have 0 left to right up 15 is our y-intercept. 3 to the right up or down 0, and 5 to the right up or down 0 are two x-intercepts. And then halfway in between we have the vertex, 4 to the right down 1. And once you plot the points, then connect the dots, and that's our graph. Okay, another example. Suppose the profit in dollars of a paint manufacturer selling X gallons of paint is given by this formula here. P of X equals -0.1 x squared plus 4x minus 30. Okay, so the y-intercept, which here in this context represents the overhead cost, be the profit at time 0, be 0 plus 0 minus 30, which is -$30. That's our overhead cost. X-intercepts in this context would be the break-even points. We want to set this equal to 0, minus 0.1 x squared plus 4x minus 30 equals 0. We're going to try the factoring method. If not, we'll use the quadratic formula if we can't get that. Okay, so we have a common fact. We want to factor out the coefficient of x squared. That's -0.1, so divide each coefficient by -0.1. Inside parentheses, that will give us x squared minus 40x plus 300. And then we need x times x is x squared. We need two numbers to multiply to 300 and add up to -40. And what works is -10 and -30. And you can check with the FOIL method. X times x is x squared. Outer product is -30x. Inner product is -10x. Combine those, you get -40x. Last times last, -10 times -30 is 300. So then we'll use the zero product rule. If you have product equal to 0, one of the factors is 0. Well, -0.1 is not 0, so that leaves two possibilities. Either x minus 10 is 0 or x minus 30 is 0. Solve each equation for x. Add 10 to both sides, you get x equal 10. Add 30 to both sides, you get x equal 30. So the break-even points are when you sell either 10 or 30 gallons of paint. Okay, so you can also do it with the quadratic formula. A is the number in front of x squared, which in this case is -0.1. B is the number in front of x, which in this case is 4. C is the number by itself, which in this case is -30. So x is equal to -b plus or minus square root of b squared minus 4ac all over 2a. Replace the letters with the numbers, so -b becomes -4, b squared is 4 squared, -4ac is -4 times -0.1 times -30. On the bottom you have 2 times a, which is 2 times -0.1. Okay, and then inside parentheses, 4 squared is 16. -4 times 0.1 times 30 we have three negatives. Negative times negative times negative is negative, and it comes out to be 12. On the bottom you have 2 times -0.1, which is -0.2. If you subtract, 16 minus 12 is 4. Square root of 4 is 2. And then you can split up the plus or minus. You have -4 plus 2 over -0.2, or -4 minus 2 over -0.2. -4 plus 2 is -2. -2 divided by -0.2 is +10. -4 minus 2 is -6. -6 divided by -0.2 is +30. Okay, so x is equal to either 10 or 30 gallons of paint, and those are the break-even. Those are the x-intercepts, but they're also the break-even points. Okay, so the x-coordinate of the vertex, you take the average of the two x-intercepts. 10 plus 30 is 40. 40 divided by 2 is 20. So it's gallons of paint. And that actually represents the number of gallons of paint to maximize the profit. And then the y-coordinate of the vertex, now that we know the x-coordinate, compute the profit, P of 20, just replace x by 20, -0.1 times 20 squared plus 40 times 20 minus 30, you end up with -40 plus 80 minus 30, which is $10. and that'll be the maximum profit. And now we have enough information to sketch the graph. Make our table of values. This is the y-intercept. That's also the overhead cost, 0, negative 30. We have the two x-intercepts, 10, 0, and 30, 0. Those are the break-even points. And then we have the vertex representing the maximum profit, 10 and 20, 10. So we plot the points. This is 0 left to right, down 30. That's the overhead cost. That's down here. The two break-even points, 10, 0 and 30, 0. And then the vertex, which represents the maximum profit, 20 to the right, up 10. And then connect the dots, and that'll be the graph. Okay, and that concludes this presentation.